Alright, in this question, we're going to do the worked out example. It says, consider two polynomial functions f and g. So basically what we've been working on is they're going to give us something like an equation and then a graph, and we're going to compare them. It says, which polynomial has a greater number of real zeros? Justify your answer. Okay, so I have the left side and the right side. I'm going to work on the left side first. Not every problem, but most of the problems. Sometimes a visual helps you. Put your finger on the degree of the polynomial. You'll notice that it is a 3. It's an odd. It should start down and it should end up like a linear, right? But this problem has a negative leading coefficient. So what that does is just switches those. So not there, not there. And then if you think about your transformations, this is shifted from the origin to the right one. So your graph's going to go somewhere right there. And then you have a odd multiplicity, so it's going to be a shoot through. So my graph might look something like this. Now if I'm using my formula sheet, it says which one has the greater number of real zeros. And I have this formula, the fundamental theorem of algebra. The degree is equal to the reals plus the imaginaries. Let's write that. Degree equals the reals plus the imaginaries. Well, class, we just said the degree of the polynomial is what? It's a 3. How do I know that? That's the highest degree. Then I need to figure out, well, this graph looks like it's always going through the x-axis. Let's make this clear. Reals are where it crosses the x-axis. Okay? Well, how do I verify that? I can do that algebraically. What does that mean? There are 3 x minus 1s. Alright, that's what multiplicity means. And what I'm going to do here is I'm just going to solve for one of these, which basically means set it equal to 0. Everyone say that. If we set it equal to 0, not everyone said that, huh? X equals 1. Okay? This verifies to you that there is 1 time it goes through there. Solve this one right here, and you get the same thing. And solve that one, you get the same thing. So basically, you have 3 times it's going through this point right there. Okay? So that means that is 3 reals and 0 imaginaries. This problem has a 3 reals. Let's look at this side over here. I'm going to use the same equation. The degree equals the reals plus the imaginaries. Now you might be asking, what type of degree is it? Well, if it's the same pointing up, that means it's a what? Even or odd? Even degree polynomial. Like something like 2, 4, 6, 8, or 10, right? Well, I'm not quite sure based on what I have. But I can do something like this. These points are called the what? Turning points or extrema. And if I look at my formula sheet, I have the most number of extrema or turning points is equal to the degree minus 1. Let's write down that formula. Extrema is equal to the degree minus 1. And how many extrema do I have, class? We have 3. So 3 equals the degree minus 1. Okay. How do I solve for degrees here? All we have to do is just add 1 to both sides. Then I get degree is equal to 4. How do I use that? Well, now I know that here my formula is a 4th degree polynomial is equal to the number of reals plus the imaginary zeros. Well, put your finger at the real zeros. Class, is that a shoot through or a bounce? So what do you think? How many is that worth? 2. Right? It's x equals negative 2 with a multiplicity of 2. What does that just basically mean? There are 2 zeros there. So it's 2. And how many here? So 2 plus 2 is 4. I have 4 reals plus how many imaginaries? 0. This problem, I have 4 reals. Well, which polynomial has a greater number of real zeros? Which side? Left or right? Right. The right side. Let's make that super obvious. Boom. This side has the greater number of real zeros. And what I'm basically doing here is I'm just comparing the characteristics of the polynomials and then figuring out the question I need to do.